What's up, Nerdgasm fans? Jerry here, aka Barnacles, and today we're going to print something with moving parts. A lot of you guys have been asking, like, hey, can this thing print something intricate instead of just trinkets like Link's shield and stuff like that? So I went and found this project on Thingiverse. It's actually a Planetary Gearbox. You can get the link in the description, but basically I upscaled it by 100%, so it's 200% of its original size, because I tried to print a small one and it didn't work out so well. So now we're going to try printing a really big one and see if we can build ourselves a functional gearbox. Alright, unfortunately I wasn't able to do a time lapse on this because it was nearly a 15-hour print and my capture software wigged out. But here we're catching the last little bit of the printing. This is the last 1% of the print after nearly 15 hours. So I'm really excited to see this thing all done and put together. You can see there 14 hours, 24 minutes. And it's at 99%. And I printed the whole thing at about 92% speed. And so far it's actually turned out really, really good. One of the bolts fell over inside of there, and I removed it from the build platform, but it was pretty much done printing, so there was like no harm, no foul there. And there's a little bit of cleanup that'll need to be done from the little stringers, they call them, that go between the gears and so on and so forth. But all in all, this is actually looking really, really clean, and it's cool that this thing can print at this resolution. Absolutely just blows my mind, and I'm gonna have a lot of fun with this project. If you guys think it's cool, I can print additional gear sets that connect onto it to create a greater gear reduction. And let me know if you guys want to see that, and I'll go ahead and do it. Now, here we have the bolt that fell off that I have in there, and you can see the textured end on it, so you can grip it easily to twist it in, and they are functional threads, which is actually really, really cool. So, well, we could go on and watch this for about the next 10 minutes, which is how long it took to finish, but let's go ahead and skip ahead to the good part. Alright, we had a little bit of a catastrophe. Nothing really to worry about. Just another piece got knocked over, and you can see there's some threads, little spaghetti, I call it, all over the place. Again, this was my fault, but it wasn't a big deal because it was almost done with the print, so I can just brush that stuff away and clean it up. But in order for your stuff to stay permanently affixed to the build platform, you got to be more careful. Alright, so now it's time to remove the pieces from the build platform, and I've got my trusty little spatula here. And I actually figured out a cool trick. Well, I ran into the problem with the air conditioner basically causing the pieces to come off the build platform. See how hard this is? Like, I'm prying and it's about ready to break it. So I was like, well, if cold makes it detach from the platform, why not just flip over a can of PC Duster? That's what I'm doing right here. See, I'm cooling the part down using the PC Duster. And I found that it actually works like a dream. The part just pops right off the build platform now. See? Pretty cool, huh? So, through my mistake, I actually discovered something to make the process better. So I'm going to let the guys at Ultimaker know about this if they haven't already done it. But just cooling the stuff down with the spray makes it infinitely easier to remove from the platform. I mean, literally, some of the stuff I was having to pry to the point where it was almost breaking. Like right there, you saw. Now watch, I'll spray it with the cool stuff, give it a nice hefty dose, and it pops right off the build platform. No problem. So, guys, if you haven't done that before, go ahead and give it a try and let me know if you like it. I want to know if this is actually a cool thing. Maybe I'll do a whole video segment on my discoveries in 3D printing, like how to make your experience a better one, because I've learned quite a few things. And again, this is one of those cool things where it's like sometimes making a mistake can be your greatest success, because here I obviously made a mistake turning on the air conditioner and it screwed up some of my print. Luckily, I didn't lose the whole thing, because losing 15 hours and all that plastic would have sucked. But at the same time, it got the light bulb over my head to go, oh, well, maybe if I super cool these parts, they'll contract just like the air conditioner did and break away from the build platform. And sure enough, they do. And you can see that right here. This seriously made it so much easier, guys. So I will be using PC Duster for everything. One word of caution, though, I sprayed a lot of PC Duster in my room upside down. Make sure you got plenty of ventilation, because I didn't, and I got a little high, and my lips from breathing it in kind of got a weird, like, I don't know, sour kind of taste in my mouth, and it's pretty nasty and hard to get rid of. So heed my warning, people. Alright, so here's the raw parts off the printer that I just detached, and some of them are going to need a little bit of cleanup. Here's the handle piece that gets printed out, and this is what you actually use to turn the planetary gears by hand. And this right here needs a little bit of cleanup too, but this is one of the pieces of the planetary gear set that holds the 3 gears in alignment. And yeah, this one I actually had to take downstairs and use a Dremel to clean up. Then you got the little gears themselves. And honestly, everything's fairly clean. The little pieces that you got to pry off and peel away are fine. But, I like using a file just to clean it up and make it really nice. So, Here I am just basically going through all the bits. And here's the other side of the Planetary gear. Now, this particular model is actually really cool because they designed it in such a way that you can actually print out extension sets to it. So when you print the first gear, you can print a second, then you can print a third, then you can print a fourth, fifth, sixth. I mean, pretty much as long as you've got space to store it. And you can, in each one will reduce the gear set more and more and more. So I saw a demo on Thingiverse where a guy had 6 of them in alignment, and he was spinning it with the drill on one side, and on the other side it was barely moving. That's how much of a gear reduction it was. And you could see right there with the bolt demonstration that I was actually able to put the nut on the bolt, and it was actually very, very smooth, and you can tighten it down. So these are actual functional bolts that I printed, which I thought was really, really cool. It's the first time I've actually printed 2 parts that go together like that, like a fastener. And here's the other piece that holds the 3 little gears. They just slide onto the little shafts here. Clean them up a little bit. But they go right onto the shaft and they spin freely. So you can tell the tolerances on this printer are actually really, really good. You're printing all these parts separately and they all fit together afterwards. So that just, that's a testament to just how accurate the printer is. Now, when I printed the really small one, it was incredibly tiny. It was so tiny you almost couldn't assemble it. So I was like, yeah, I think the person was going for how small could you actually print a functional gearbox. I decided to go the other direction and say how big of one can I actually print. So there's all the parts, guys. All right, now it's time to do a little bit of a cleanup. You can see I got just a file here, just a regular metal file. It's not even a plastic file. And I'm just going to go around where there's some little boogers in the teeth and stuff from the print head moving on and off of the object. And I'm just going to file them down a little bit. You don't have to go too crazy here. I mean, if you want the gears to be perfectly meshed and reduce friction, you might want to spend a little bit more time than I did on this. Or use an angle cut file, which I have somewhere in my garage. I just didn't go and grab it, which would have cleaned the teeth out even better. But, just do what it takes to get the gears to mesh together nicely. And that's all I'm trying to achieve right here. All right, so now we just want to make sure that the little gear moves around okay inside of it, and it did. So now I'm going to take my little gears and file them also, and those are the only other part that you really need to clean up after this print. And these required even less cleanup than the larger gear. Now, had I not turned on the air conditioner in my room and screwed with the humidity and the temperature, I'm confident this thing would have printed out flawless and came right off the board, but it's one of those things when you're 3D printing, you really don't want to change the environment a whole bunch because it is sensitive. This plastic is temperature sensitive, and the rate at which it cools is actually, a critical working part of how it works. If the parts cool or solidify too quickly, they won't fully bond with their surrounding and you'll have a weak part. If they solidify and stay, or they stay a liquid too long, the plastic stays a liquid too long, then you start to get this blobbing effect. And, so there's a lot of tweaking and tuning that you do in the software to actually get the printer working right. And it's one of those things where it's what might work in my environment in my room might not work in your environment in your room. And there's some variations in the printers too, where, you may need to make adjustments or print at a higher temperature or a lower temperature depending on just variations in parts. So just something for you guys to note if you get one of these printers. Out of the box, they print really well, but if you stick with it and you learn with it and you keep printing, you're just going to keep getting increasingly better and better prints. But it is a process of definitely learning the machine and becoming used to how it works. And the result is you get much better prints. All right, so now it's time for assembly. So you start off with this little piece right here, and this holds the 3 little planet gears. So you go ahead and put those on there. And they actually spin really, really freely, and they don't have any play in them, which was nice. So that just is a testament to the tolerance of this thing. Then you take the larger gear, and you put it on the outside of those, and then you slide the handle through the middle. So the handle's actually turning from the inside, and then the outer planetary gear is what's guiding the planets around, if that makes any sense whatsoever. So once that's all lined up, which I'm doing right there, now what you want to do is take the back piece, which slides and snaps on there into place, and then you want to line everything up so that you can run the bolts through it. And that's what I'm going to do right here. I've actually got the bolt in the wrong side. Flip it around, give it the program, Jerry. There we go. Okay, so now we're going ahead and slide it through. And because all 3 holes are threaded, they stay exactly where they're supposed to when you slide through the other side. And so just like that, tighten up. And of course I grabbed the wrong nut here. That's why it's not screwing on. I'm like, oh, what the hell's going on here? I've been fooled. No, it's one of the smaller ones. So I'll come back to that. So if I could only keep my hands in front of the damn camera. Gosh, I swear I need a laser pointer pointing at the desk so I don't do this. So you guys can just sit there and watch my palm move about. Well, there's nothing interesting going on here, but I'm going to leave it in the video anyways, because that's how I roll. Guys know I like to error my mistakes. But you can see I'm spinning the Planet gear. It was actually working right there. So I'm like, woohoo, I'm super excited right now. I think I even yelled Yahoo, but I decided to do this as a voiceover video since my microphone picked up the air conditioner so freaking loud. So, and you guys have actually liked the voiceovers, so that's why I keep doing them. If you don't like the voiceovers and you'd rather me just do live commentary, I can do that too. That's fine. So there I am, screwing the little bolts on the end of the nuts, or the nuts on the end of the bolts, blah, 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 blah. Man, I'm absent-minded today. And there we have a functional Planetary motor handle. No, there we go. Now you can see it. Ta-da! So you can see that I'm rotating the handle on one side, and it's not spinning nearly as fast on the other side. And it actually moves pretty freely and pretty smoothly. And you can pop the handle in and out really easy, as I show you right there. And you can see you can go forwards, backwards. It works actually really, really well. I was actually surprised, and I'm still playing with the thing now because it's just so freaking awesome. All right, here I did just a little bit of fine-tuning and tighten things down. So now you can see all the gears moving inside as I'm rotating them. And keep in mind that what you're looking at right here is 100% 3D printed. There is not a single part in this Planetary gearbox that didn't come off that printer and isn't plastic. So there's no metal, there's no bearings, there's nothing like that. This is 100% printed in PLA plastic, and it works fantastic. Wow, that kind of rhymed. Now, the next step that I'm going to go to is I actually broke a couple little parts on it. I know I'm bad. I decided it'd be awesome to hook it to drill and see if I could spin it at like 3,000 RPMs. And obviously what happened was the shafts heated up and they bonded to the gears. So I need to print a couple new replacement parts, just the little parts, so it's not going to take 15 hours again. But next time I'm going to add some silicone lube to it and see if I can actually get it to withstand that 3,000 RPM or whatever the hell my Craftsman drill does. So let me know if you guys would be interested in seeing that as this progresses. Like if you want me to add more gear modules to it, I can certainly do that. And if you guys want to see this thing like try to go for broke and run at incredibly high speeds, let me know. I'll push for that too, and we'll do them as separate videos. But for right now, guys, I hope this gave you a nerdgasm. It sure as hell gave me a nerdgasm because I mean, come on, I printed a freaking transmission basically off of a 3D printer. I mean, that's awesome. So if you don't think so, leave it in the comments. Like, favorite, and subscribe. I love reading your comments. You guys know I do. Check out my other videos, please. I'm having a lot of fun interacting with you guys, and the channel's actually getting really big. So someone out there must like me. So guys, until next time. I really hope you enjoyed this video. If you did, please like, favorite, and subscribe. It helps me a bunch. Also, come follow me on Facebook and Twitter. I love interacting with you guys.